A very good morning to Madam Ami. Today we are going to discuss about lab module 3, which is per unit transformer, and my name is Nawanida Anlaki Twairaj. My matrix ID is 211291020. So basically the objective of this experiment is to determine the per unit value equivalent circuit for the system given, to simulate the system using power wheel, to solve the complex power delivered by the generator from the single line diagram, to maintain the voltage level within the prescribed boundaries using shunt component. And the tools are power wheel software. And for this experiment, this is the diagram which are going to be drawn in power wheel software. But beforehand we have to do a pre-lab calculation before to actually compare the values. So I've already done the pre-value calculations. For my V base, which is V base 1, I have 222 kilo voltage. For my base 2 is 22 kV, which times with 202 kilo voltage over 22 kilo voltage equals to 220 kilo voltage. For my base 3 is 220 kilo voltage times with 11 kilo voltage over 220 kilo voltage, which is equals to 11 kilo voltage. And as for Z base, this is the Z base formula, and this is the Z1, which is 22 kilo square over 50 MVA, which is equals to 9.68. For my Z2 base, which is 220 kilo square over 50 MVA, which is 968. And for my Z3 base, which is 11 kilo square over 50 MVA equals to 2.42. So my XT PU new is XT 0.1 times with V old over V base square times with SO over S base. So basically the values are 0.1 times with 22 kilo over 22 kilo square times with 50 MVA over 50 MVA. So which is equals to 0.1 PU, and my X line PU is X line over Z base, which is 100 over 968 equals to 0.1033 PU. So now let us move on to the simulation part. I'll demonstrate the simulation. So this is the circuit. I've already drawn the circuit, and as for the bus 1, according to the lab, we will be using 22 kilo voltage, whereby the T1 is equaling to 50 MVA, which is in bracket x equals to 0.1 pu, and below that is 220 kilowatt. And this one will be 57 MVA, 22 kilowatt, and which is we did the power factor of 0.6. And between bus bar 2 and 3, we'll be using T line, will be x equals to 100 ohm, and we're using 220 kilovoltage. And whereby bus 3 and bus 4 will be using 220 kilovoltage T2 equaling to 50 MVA in bracket x equals to 0.1 pu and 11 kilovolt. So this is the circuit. Now I'll be simulating the circuit for you. Sorry. Okay. So we can actually look at the results. So I'll zoom in for you. Okay, as you can see, this is the volts, this is the angle, this is the load, and this is the load for MVR, and this is Gen MW, this is Gen MVR, and this is for the switch shunts MVR, and that's it. So now this completes table 1. So now let us close this window, and now let's increase this value to 1. Okay, so stop it, and let's increase the value to 1. Sorry. So it's increasing. Okay, this value reaches 1. So now let us go for the table 2. And this is the value for table 2. This is the value of volt, angle, and this is the load MW, this is load MVAR, this is gen MW, this is gen MVAR, and this is switch shunts MVR. And this the value. Since the values are not really clear in the video, I'll show you. Okay, this is the nominal kV, this is the PU volt, this is the volt kV, angle, load MW, load MVAR, this is gen MW, gen MVR, this is switch shunts MVR. So this is for table 1, and I'll show you table 2. So this is table 2. This is nominal kV, PU volt, this is volt kV, angle, load MW, load MVR, gen MW, gen MVR, switch shunts MVR. So this is the. So basically I've shown you the demonstration. Now this is the result of the table, and this is the result of table 2. So now let's jump on to discussion. For discussion, the representation of system quantities as fractions of a certain base unit quantity is what is referred to as a per unit system in the field of electrical engineering's power system analysis. Calculations are made easier as a result of the fact that the amounts that are specified per unit do not change when they are transported from one side of a transformer to the other. And in conclusion, we are successful in estimating the per unit value equivalent circuit for the system that was provided to us and simulating it with the help of PowerWorld. A further capability of the single line graphic was that it enabled us to compute the complicated power that was supplied by the generator. Finally, by utilizing the shunt component in this experiment, we were able to maintain the voltage level within the parameters that are required. So with that, thank you for listening and have a nice day.